extremely effective. Mentoring can actually make somebody's strength look stronger because you can use it in the right way. And students and anybody in throughout your career, seek mentors and look for people who can spend some time with you sharing their experiences. You don't want someone to tell you do this or do that. Mentors don't do that. Okay, I don't do it. But if people actually suggest a certain situation they are in and what they're thinking about, I can offer my perspective on similar things that I have gone through and what worked for me. And then it's up to the mentee to look at whether to take that in or not take that in. At least they are better educated. So thanks again, Amritkaal, and kudos to all of you for joining this initiative. Well, I think I'm hoping that, okay, I mean, Amritkal is going to put different people in front of you with different backgrounds. I'm going to talk a little bit about how wireless technology is impacting all of us and how people can prepare themselves for what's going on in the world and maybe use that to change the world. Okay. So I come from Silicon Labs. Whenever someone talks about something, it's one way is that that person can read about it and talk about it. The more effective thing is that the person talks about what he has experienced, what he has gained insight on, worked with other people and gotten his hands dirty and over a long period of time. That actually, filters that information and brings out what's useful. So I come from Silicon Labs. I've been here for the last, I think, 23 years now, and before that in other chip companies. It's not just semiconductor design that I've been working with, complete systems, embedded systems, became IoT. And I was part of actually seeing that happen and making it happen myself in many ways. So it's been a nice journey. And Silicon Labs is a leader in wireless connectivity for IoT. I'll talk about a little bit about what's different in IoT wireless compared to other wireless that's there on your cell phone. So Silicon Labs is a leader in connectivity protocols like Bluetooth, Wi-Fi, Thread, Z-Wave, Sidewalk, Wi-Sun, and many other things, which I will talk about. And our products, our chips actually empower a lot of new gadgets and applications, including smart meters, smart thermostats, medical electronic products, and so on. I'll talk more about it. Okay, so the world, speaks lots of languages. Communications is about making sure the information that you have has reached somebody else. We talk. I'm talking to you right now in English, but there are many other languages. I can talk by writing a mail. I can communicate by sending a message, or I can record a video and show it. In many ways, the world is full of languages and so on. Unfortunately, even in the technology world, when devices send data to other devices, again, there are lots of options. And you're never going to have a single way of communicating across the world, across devices. Okay, you have the wired world had a few. Okay, you had Ethernet, very popular, USB, very popular. Ethernet, maybe people are not using anymore. USB people certainly are using still. You had RS-232. I don't know, maybe none of you are old enough to remember RS-232, Modbus in the industry. On the wireless side, there is a plethora of standards. Okay, there are lots and lots of them, and there will be more coming up every year. Okay, so, but why do we need so many? Firstly, the fact that the spectrum you can talk in or communicate in is a wide range. And what do you mean by spectrum? It's actually a frequency. Okay, if you open your FM radio and tune into, say, 101.9 or 108.3 or whatever. Okay, so all of these frequencies are there to be used, and you can use one of them. If you're using one of them, somebody else can use some other portion of this, some other frequency. And as long as they have some filters to remove other frequencies, they can communicate and you can communicate at the same time without impacting each other. Imagine if you are sitting in a room and talking to somebody and your neighbor is talking to somebody else. We are both using the audio spectrum. So what I speak can interfere with what somebody else is speaking. And someone who's listening can listen to two at the same time. He has no way of filtering. But in Wireless frequencies, the amazing thing is that you can put a filter in front and then you can remove everything other than what you want. And these frequencies are just physical phenomenon. They cannot be created, they cannot be destroyed, right? So frequencies are allocated very stringently and everybody seeks different things. Okay, at the very low end of the spectrum, you have long range communication which ships use. You can also use it for navigation. Before GPS came in, they used very low frequency signals for determining where you are on the earth. Okay, and then we had the AM radio, okay, which I don't know if some of you still use it, but it is there. AM radio is there. Then you have shortwave radio, which I used to listen to when I was a student. I used to listen to, Voice of America and the BBC and Radio Australia. No internet at the time, but I could listen to the news from London or from Washington DC on shortwave radio. Okay, because those radio waves actually they hit the ionosphere and reflect back, so they can go a long distance. Okay, and then when TV came and they had VHF and UHF. Again, none of you might have used it anymore, but when I was young, we had TV, which had an antenna on the top, and there was spectrum allocated for it. Then, as the frequencies go higher, there was satellite communication. Satellite communication started a long time back in the 70s when India launched the first satellite. Satellite communication is what makes a lot of these dish antennas work. You are sending it signals and then you are receiving it from your dish. It's also used in a lot of two-way communication. People who are going out in space, okay, they send you can talk to them, you can see them, and they are all using some very high frequencies there. So all of these frequencies are available, all of them are allocated for different purposes, and people, it's like land. You cannot make land anymore. Once you get something, you use it the maximum way you can. Okay, so but many years back, about 20, 30 years back, okay, all the governments, I mean, there was a very nice initiative saying that a spectrum belongs to people. I mean, you might all have heard about the fact that for cellular communication, I mean, Geo and Airtel have paid lakhs of crores of rupees to get the right to transmit in a particular piece of spectrum. But then, I mean, people have to pay money to actually communicate that. Then they started something called a license-free band for industrial, scientific, and medical purposes. And these frequency band, 900 megahertz, 2.4 gigahertz, 5 gigahertz, and you also have 60 gigahertz. These spots were open to everybody, and therefore people can use it, but the rules were different. Okay, how are the rules different? Okay, I mean, let's look at it. Okay, so on the one hand, you have the Geo and Airtel who paid lakhs of crores of rupees to own the spectrum where they can exclusively operate in a particular area. Okay, so the same frequency in Hyderabad, which Geo has paid for, maybe that frequency in Bangalore belongs to somebody else. Okay, so it's having a limited range. Within that range, you are the only person who can use it. It's like, going and renting the cricket stadium in Uppal to play a cricket match. The whole field is for you. You can play cricket the way it's supposed to be played. And then you have other, grounds which are open grounds. Anybody can use it. On Sundays, you will find about 5, 6, 10 different matches happening in this. This is like license-free spectrum. And because so many people are using it, the rules are different. Okay, you cannot, for example, use a hard ball. You cannot put a fielder in front of somebody's, wickets. There are some rules which are different. Similarly, in the IoT, which uses license-free spectrum, the rules are different. The amount of power you can transmit is different. The way you are a good neighbor, it's called listen before talk. Don't talk until the channel is silent. Rules are all different. And once you have followed all the rules, then everybody can communicate easily and for free without paying too much. Okay, so because of the fact that spectrum is spread across different things, and because of the fact that people are using wireless communication for different purposes, different standards have come. For example, everybody has used your access card, whether you're using in your college or or entering a building or entering a metro train. Okay, very small range. You have to literally touch it. Okay, you're not actually touching it; it's still wireless, but you have to go really nearby, and then it communicates. Similarly, if you go to the highways and you have the fast tag, the car comes quite close to that, not as close as your card, but you need to come close and then it reads you. That's called near field communication. The standard is different. Then you have Bluetooth Low Energy and ANT plus. It's like your smartwatch sending data to your phone, your heart rate and everything else. Okay, so it's again, I mean, you're not going, if your smartwatch is in the next room, your phone cannot read it. It's low range, little bit higher data rate, about 1 or 2 Mbps. Then you have Zigbee for home, okay, which is 250 kbps, and it covers the home, and it's actually a kind of a mesh network. Data hops from one to the other, one to the other. For example, Bluetooth goes from the device to your phone. That's it, over. Okay, and then you have Wi-Fi, okay, which everything goes to a router. You know, every home, every office, every college has a Wi-Fi router. The Wi-Fi router is present in every hall in your home. Maybe you keep it in a centralized place. All data goes to the router, and from the router it comes back here. If you want to send a message to some other device, you want to control your TV through your phone, it goes to the router and comes back. More often than not, it goes to the router. From there, it goes to the internet and then comes back. Just like a WhatsApp message you're sending to your friend who's sitting right next to you, the data goes to the router, the router goes to the internet. From the internet, it comes back and does. So this is called a star network. Everything goes to a central node. Our cellular network is also star. If you are in access, if your cell tower is within range, then you send data to it. You cannot send a message or talk to your friend when both of you are outside coverage, because Airtel or Geo, they are the ones who own the spectrum. Okay, everything has to go to the tower, everything has to be built, everything has to be paid for. This is not license free. Wi-Fi is license free. So you can actually set up a direct link also from Wi-Fi to Wi-Fi, and you can share photos and so on. Whereas in cellular networks, you cannot. Everything has to go through the base station. So there are some applications that requires a video. Video requires high throughput. That's why the Wi-Fi has grown in throughput. I mean, the cellular has grown in throughput. Right now, you can get a Gbps, or if you take 5G, you can easily see some 300-400 Mbps at least on your phone. Multiple people can download and watch their own movie at the same time because the bandwidth is so high. Each movie takes a few Mbps. Okay, it can be as low as 1 Mbps depending on the screen size. It can be 7 or 8 Mbps or even 15 Mbps. But remember, if you have 300 Mbps of download speed, in your area, 20 people can see very high definition TV, or hundreds of people can watch on the smartphone. So the higher the data rate, the more applications and the more number of devices can be handled. So all the engineers in the world who have worked on creating these standards have looked at what are people doing. Okay, they are watching lots of video. There are hundreds of them in one particular area. So you have to make it denser. Okay, and then there are many devices which are battery operated. They have to be able to send and go back to sleep, and conserving battery as much as possible. What can we do to enhance that? So performance, power consumption, density, all of these problems have been solved by the cellular engineers as well as the Wi-Fi engineers. And again, you will have Bluetooth, which is there all the time. And new technologies come in like Voice Sun, which is for smart metering and smart cities. I'll talk a little bit more about that. Okay, Wi-Fi, okay, everybody knows, okay, it's not static, it keeps on evolving. The speeds keep increasing, the capabilities keep increasing. And in fact, actually, the number of use cases of Wi-Fi is increasing all the time. We would never have believed 10 years back that every TV will have Wi-Fi, and you can, throw your cell phone video onto your TV and watch it, right? Earlier, at best, okay, you might have to have a thick cable, HDMI cable. Okay, now everything is, the Wi-Fi is evolving with the needs of the people. Okay, so now let's focus a little bit more on the license-free spectrum. Okay, so one of the things that has happened is that the home is becoming full of devices. Okay, everything is Wi-Fi controlled, Bluetooth controlled, your smart blind, smart light, smart TV, smart door lock. Okay, the electric charger for your car, you can monitor it on your app. Everything is becoming remote controlled. Okay, you don't have to get up and walk. Even to a washing machine, you can check the status on your phone in many of the new washing machines. And if your fridge door is open, you get a message flashed on your TV saying that somebody forgot to close the fridge door. Okay, things are getting smarter, and you as engineers can work to make them even more smart as time goes by. Okay, now it's not just in the home. In the city also, we are seeing a lot of applications. A lot of street lighting is getting smarter. The street lights are getting controlled. People are actually seeing what the light intensity is like. I mean, it's very simple, of course. I mean, not to have a person switch on the light at 6 p.m. and switch it off at 6 a.m. Unfortunately still there in some places, but everything is getting smarter. And because you have a connection there, street lights can also become monitors of air quality, for example. You can actually put an air quality monitor there. You can put a temperature sensor there. You can put a video camera there and look at accidents happening on the road and immediately raise an alarm, even without anybody looking at the video later on in person. Then energy management, security, turning lights on and off, all the AC is being controlled, and everything is getting automated through the use of wireless communication. Okay? And then environmental monitoring in heavy industries, storage and distribution, and a lot in agriculture. Everywhere devices are coming and devices are getting smarter because they're able to talk to each other. Okay, so let's look at what is there a little bit more in the 2.4 gigahertz band. Everybody, became familiar with Bluetooth early on because of the fact that you can have your own speaker. And it seems amazing that, okay, you can just connect your speaker and then you can get all your sound into your headset without having to have wires dangling somewhere. And the amazing thing was that two people can be sitting in a bus. Each of them can be listening to music on their Bluetooth headset. They will not interfere with each other. Okay. Like I said, frequencies, even though the Bluetooth frequencies are same, there are mechanisms by which the interference is removed. So the Bluetooth, everybody became very familiar with through the transfer of audio. But the only problem was that it required a little bit of a battery, which is a little bit bigger. Then they thought of applications, like smartwatches, or Nike introduced you, okay, some small sensors in your shoes. Okay, you can buy a Nike shoe with that sensor, and then that sensor would, count your steps and count your speed and everything else, but it will transfer the data to your phone. And then they found that, okay, I mean, how can you keep charging your shoe, right? You don't want to charge your shoe. You want that to run for 1 year without charging. So how can you do it? So you have to make the protocol more energy efficient. So they modified the protocol and they called it Bluetooth Low Energy. They did things there which will make it energy efficient, therefore a long-lasting battery. And the other advantage of that was that the batteries could also become smaller. You can have small rechargeable batteries so that you now have miniature bands. You can have a ring which is having Bluetooth in it. Imagine, I mean, there's apart from electronics and an antenna, there's also a battery in it, right? Amazing, and it's charged, okay, wirelessly. So amazing things have been happening because the power consumption has been brought down, and that's Bluetooth Low Energy. And today, everything is Bluetooth Low Energy. Audio is also becoming part of Bluetooth Low Energy, and soon Bluetooth Classic will go away. Okay, and then you have something called Zigbee, not very popular here, but very popular in the US. It became very popular because they did the home automation there. When you say home automation, all your devices in the home can be controlled by a central hub. They used to put a display there. You go to your display. Okay, my garage door, what is there? What is the temperature in the living room? In the bedroom? Can I set it? Okay, can I open this window? Can I close this blind? Okay, so this had everything there, which made it possible through a kind of a mesh network. Okay, not very popular here, but in the US it is still very popular. And then they thought about going beyond. So Wi-Fi works in the home. Everybody knows that. If you step out of your home and go down 2 floors, your Wi-Fi goes away. Okay, if you have an independent house, you go to the street, your Wi-Fi goes away. But what the only recourse there is to have a cell phone, or if you're having a device, you can actually put a SIM card in the device and you can make your device also a cellular connection. So a lot of things, okay, a lot of people have been creating those, those bicycles which are or which you can hire, or scooters which you can hire, and you can actually use the app to find out where this bicycle is, and then you can go there. The connection there was predominantly cellular, and cellular means monthly charges. which means SIM card and monthly charges. Then they thought, why not use license-free spectrum for long range? So there are multiple low power wide area network technologies. LoRa is one of them. A lot of students do projects using LoRa modules. It will go about a kilometer or more. Very small amount of data you can transmit, but you can figure out that, okay, I mean, yes, you can send sensor data, not for video or voice calls, but some data can be sent. Okay. And wireless LAN has been the most spectacular of all. Okay, if you can look at how it has been evolving from 1999. Okay, so I was involved in defining the standards 802.11g and 11n. I was part of the group which actually defined it. I'm still part of the Wi-Fi Alliance and the 802.11 working group, which is defining what we call now as the Wi-Fi 8 or 802.11bn. And Wi-Fi 8, okay, will not only have high throughput, but will also be very reliable. And it is going to be able to make Wi-Fi work for controlling machines, for enabling smart traffic on the road, driverless cars. How can they get real-time updates within a millisecond, whether something is coming, they should stop, and so on. So Wi-Fi 8 is going to make a lot more inroads into a lot newer applications. But you can see that over the years, the data rate has been increasing 54, 450, 6.9 Gbps, 9 Gbps, and currently a lot of routers are Wi-Fi 7, which is 46 Gbps. Okay, and technically, okay, engineers have done it by doing a lot of research, signal processing and communications technology, chip design technology, and putting in new ways of doing or better ways of using the spectrum, better ways of energy conservation, and so on. Okay, so engineers have done a lot of new things for doing it. Now, this is actually in the 2.4 gigahertz band and the 5 gigahertz band. There's also another band called the sub-gigahertz, less than 1 gigahertz, which has some unique features. First of all, okay, I don't know if any of you have ever seen this, let alone used it. Okay, so we all used to have an antenna like this on the roof. We used to watch a TV like this, and there used to be a TV tower. Okay, in Hyderabad, it was in Malakpet. You could actually see it, and from there, it would reach over the city. Now the city has grown so much that I'm sure that will not reach all parts of the city, even if it were there, but it's all gone now. Okay, so remember that when a big building is there in a piece of land, and suddenly that building is cleared out and broken up, now the land is free. Everybody now says, I want that land, I want that land. Similarly, everybody is wanting this frequency. They are calling it a TV white space. White means there's nothing there, blank. Okay, so it's an open piece of land. Can I use it? Okay, and lots of people are proposing lots of ways in which it can be used. And what are they doing? First of all, you must remember that at that frequency, the range can be quite long. So TV signals used to go tens of kilometers. Okay, and if you have tens of kilometers that you can go, what all can you do? Okay, you can actually do, I mean, cellular offload. That means that if you are in a bad area and you have a cell phone tower very far away, okay, and cellular folks are not going to let you, put a new tower. Maybe you can use license-free spectrum, okay. I mean, assuming that this is made license-free, okay, for extending your cellular network, okay, because this can go a longer range than the many of the cellular networks. Then you can use it for infrastructure monitoring because you can use it across the city. You can use it for border protection, okay, where you can install new networks for emergencies. Then you can use it for rural internet backhaul. That means that, I mean, forget about cell phone means for talking and so on. What if every village had at least a nice Wi-Fi connection? That Wi-Fi connection, which is broadband Wi-Fi connection, remember, if you go to rural places, you will still get a cell phone signal, but your data rates are going to be low because they are a little bit far away. They are getting aggregated across hop by hop, and so many people end up sharing that bandwidth that you're not going to get high data rates. But what if you use Wi-Fi? Every phone has got a Wi-Fi. Let that data be good, even if the cellular connection is just enough for voice. Can use it for rural backhaul, okay, or broadband, and can use it for last mile connectivity. Okay, I mean, India has got a nice fiber optic network. Fiber optics gives you a lot of bandwidth. They're underground cables. They are not interfered with because they are all on the cable. And almost more than 6 lakh villages now have fiber coming there, okay, to the central point in that village. But from there, you have something called a last mile access. From there, how do you take it to the home? Okay. I mean, if the home is within 100 meters, Wi-Fi will work. If the home is half a kilometer, 2 kilometers, different technology. Okay. And the TV white space can be one of them. And can you monitor forests? Can you monitor agricultural fields? So a lot of people are looking at how we can use these. Okay, so and then okay, Wi-Fi also is trying to look at it called a standard called Wi-Fi Hello. If you so one of the things that people found is that you have all kinds of Wi-Fi devices in your house. Okay, so you are all putting in a kind of a router, and the router is talking to everything. But what if you have a big house with a big garden, and you have something in your gate? For example, you have a video monitor on your gate, okay, or you have a water meter somewhere at the end of your garden. Suppose you have a sewage treatment plant, okay, which many countries they have, okay, in your garden. How can you monitor it? How can you reach, okay, I mean 100 meters or so, okay, and then Wi-Fi Halo is one way of doing it. So this is also available, but not very popular right now. Okay, and then India, I mean, the whole concept of smart cities came. That means that devices have to be monitored inside the city. There's lots of applications that enable interworking between different departments, especially mobile ones. If you're not mobile, you can lay cables in the city. You can use your fiber optic cables and everything, and all of them can be used. But if something is moving, something has to be portable. And suppose you have a street light and you want to put a sensor on top of it for measuring air quality. No problem, power is available. The street light has got electric power. But what about communication? Of course, you can always put a SIM card there, and the SIM card can actually, take data. I mean, transmit your signals on the cellular network. But then SIM card means you have to pay for it, and it doesn't become very cost effective because you're going to lay, I mean, lakhs of these around the city. So India actually allocated a spectrum called spectrum, which is at 865 megahertz, which is less than 1 gigahertz, for smart city applications. And they approved a technology called Wi-Sun, which is a mesh network, which means that you can go hop to hop. You don't have to put a central tower. A star network is everybody talks to the tower. Mesh network is that you can talk to your neighbor will forward your data. Eventually, some node will be in range of a tower, and then they send it. Okay, so that's called a router, a border router. So thanks to the fact that the government has allowed it, a lot of smart metering has become into Wi-Fi. So what is a smart meter? You know that, okay, I mean, whenever you have electricity meter in your home, every month somebody comes and takes a reading down and goes back, then bills you. Now, a smart meter is something which electronically measures and can communicate wirelessly. Okay, a semi-smart meter is when somebody comes there, the display is there, then they put a wire or take a device close to it, and then they read it. But the ideally the power department, the transmission companies would want to take the real-time data as and when you are consuming into their network. Then you can even have a prepaid power connection. That means that you are taking connection, you are actually you're paying for it, and as long as you have balance, you can continue. Okay. The postpaid is what we are using. Then you have to go and pay the monthly bill. If you don't pay the bill, somebody comes and cuts it off and so on. But having a smart meter enables the department actually to plan out what is the demand, what is the load, what should I do? Should I reduce power somewhere and increase here? All kinds of things can be done to better distribute the power. Now, they don't, of course, you can always connect your energy meter in the home to your Wi-Fi, or you can connect it to cellular. But connecting to Wi-Fi, the energy companies want their own network. They don't want to depend on the fact if you turn off your Wi-Fi, then they cannot read what's happening in your house. So they want to have their own network. So Wi-Fi is a way of creating that smart utility network. And once you have a smart meter, you can actually use it for controlling and managing the power consumption inside your house. For example, let's say that if you take too much current, your meter may trip, your circuit breaker may trip. So if you are having your AC compressor on, maybe the washing machine can be off. The washing machines, the motor can be turned off. Once the AC compressor goes to off mode, maybe you can turn this on. So a lot of smart things can be done to make energy consumption little bit more even and more reliable. So smart utility networks and all homes will soon see that the smart metering, okay, use something called Wi-Fi. Okay, and then there's another band called the millimeter wave band, which is at a very high frequency. Okay, 60 gigahertz. Now, 60 gigahertz, okay, is compared to 2.4 and 5 is, I mean, more than 10, 20 times. So it's a very, very high frequency, very small wavelength, millimeter wavelength. Okay, each antenna is proportional to the size of the wavelength. So if you open a particular device with Wi-Fi, you see an antenna like an F. Okay, that antenna like an F may be about 5-6 centimeters because that's like the kind of wavelength of Wi-Fi. Okay, so the minute you have millimeter wave, the antenna can become quite invisible. So you can actually do a lot of different stuff with it. Okay. And there are lots of new applications that can be done. Firstly, a lot of frequency spectrum is available. Okay, the frequency spectrum is logarithmic. At 60 gigahertz, plus or minus 10% means that you're talking about 6 gigahertz, 6 gigahertz, 12 gigahertz. If you're talking about 2.4 gigahertz, plus or minus 10% is only 240 megahertz. Okay, much less than 6 gigahertz, right? So the higher the frequency, the more the bandwidth you get. And and strangely, I mean, 60 gigahertz is the oxygen absorption band because the oxygen molecules in the air absorb the radiation, and because of which the range is very small. By the time you go across the room, the oxygen in the room has already killed the radiation. Now, this is an advantage. Why is it an advantage? You can actually stream your own high definition TV in your room, and these signals are not going to penetrate the wall. It's not going to reach beyond. So your neighbor in another room can do his own high definition TV in the same frequency band without getting interfered with. And that's why they are thinking about a lot of things like cordless computing. Okay, I mean, why connect wires to your laptop? You just do 60 gigahertz transfers at a very high data rate. You can use external storage, you can use external monitor. Nothing needs to be wired up. Okay, and if you want, let us say that you're going on a flight, you want to download a movie to your phone. Remember that if you want to download a movie, it takes half an hour or so, maybe 20 minutes in your home. If you have Wi-Fi, if you forget to do it, if you go to the airport Wi-Fi is very slow. Airport cellular connection is also slow. But then you can have, if you have 60 gigahertz on your phone, you can go to a kiosk and then you can select a movie, keep your phone in front of that kiosk, okay, and pay a small amount of money. And then within 3 minutes, you will have a complete movie on your phone. Okay, so new technologies can create new applications. So on the one hand, people create technology. On the other hand, people create new ways of using the technology. So as engineers or as innovators, I would say, we need to keep looking at, okay, so I want to do my own, let's say that we are in the field of, fashion design. I want to use technology. So how can I use it? Okay. I mean, how can I collect data from things walking, people walking? Can I scroll through all the channels automatically and figure out, okay, what is commonly worn today across all the TV shows? Can I summarize all of it? And can I get suggestions on how to create something new? AI taking data in. So people always have to keep looking at somebody has created some technology. How can I use it? How can I create it and use it in my own domain? Okay, and then we will not forget cellular. Okay, we will still talk about the fact that cellular communication is also evolving. Okay, now when it comes to 5G, we spoke a lot about. I mean, there's a lot of 5G networks everywhere. Everyone thinks that 5G means you get equivalent to Wi-Fi kind of data rates, right? Suddenly, okay, if you have 5G network wherever you are, you can watch a movie without, things breaking up or getting that stop and go kind of thing, right? Fine, that is one of the things of 5G, very high data rate for everybody. But there are other things also. This we call it as the enhanced mobile broadband. Okay, you can go up to 20 Gbps. You can use it for internet. You can use it for video on demand. You can use it for augmented reality. You can use it to watch, sports shows. You can actually do picture in picture. You can see two cameras at the same time, okay, in a sports stadium. All that technology is already there. It's coming in. But apart from this, what else can we use? They want to use 5G for something called a mission critical application. A doctor sitting in Bombay operating on a patient in Nellore through 5G networks. And our Prime Minister has actually gone and demonstrated some of these, inaugurated some of these. What is important there is very reliable, very low latency. Because if the doctor is actually controlling a machine which is operating on a patient, the latency has to be very quick. The doctor is seeing and then he is doing, and if he sees something wrong, he has to react immediately. If the picture comes to him after 3 seconds and his response goes after 3 more seconds, by the time the damage is done, it has to be almost real time. So very low latency communication is offered by 5G, where you can do remote operations. Okay, let's say that people are going into a mine. You've seen many news reports of disasters, right? Miners go in to operate the equipment, then something happens, and then they cannot come out. Okay, it's a very hazardous environment. But why should that machine have person operating it there? Is someone digging by hand anymore? No, that's all gone. Everything is dug by machines only. Everything is processed by machines. Everything is carried by machine. The people are there only to operate it. Why should somebody actually be there to operate it? Okay. Can he not operate it from outside? That is exactly what is happening now. Okay, the machines are there underground, the controllers are there outside. Okay, and that requires very fast and reliable communication. A lot of hazardous industries and drone control and everything. Okay, they can all use 5G technology. The third type is that it's not mission critical. It's not very low latency. It is just lakhs and lakhs of devices. Okay, if you take a particular square kilometer, okay, the number of, you have these eSIM cards. You don't even have a physical SIM. If the cellular world wants devices to be connected to them, okay, there can be lakhs of them in a particular area. So today, if you have a cell tower, if say 10,000 people are trying to access it, it's gone, over. Okay, so the more crowded places you go, the more difficult you have for cellular connection. But what if you're having something which is going where you have tens of thousands of devices, but they're all sending small amounts of data? Can you accommodate that? Yes, 5G is able to accommodate that. And all of those devices, many of them are battery operated. So can you create a way in which they can consume less battery? Okay, so 5G allows to do that. Okay, so not only the high throughput, but also the latency, low latency, and the IoT applications are being addressed by 5G. Okay, so just wait a minute. I think I have to put my charger on my laptop. Hang on, I'll be back. All right, so about all the new applications, I already told you about the smart meter, so I won't go in for that. But the idea is that the energy meter should also be able to control and configure your appliances. They should be able to see what's going on in the house, and should be a kind of a place where a lot of intelligent software comes in, so that you can control the devices in your house so that they are most energy efficient. In many countries, they have this demand-based pricing. Now, today, if you use Ola or Uber, suddenly when there's demand is more, you actually spend more, right? So similarly, when energy demand is more, you pay more. So how can you distribute your work so that you can do it at the right time, okay, when the energy cost is low? Okay, so industry 4.0 is coming up. Okay, tools are getting controlled. Let's say that you have an assembly line where people are assembling something and they're using a smart screwdriver. This is actual application that one of our customers is doing. When a new part comes on the assembly line, the particular, the torque to be applied changes. So in here automatically it is the data is sent here so that people don't have to do things manually and it's automated. A lot of automation is happening in the industry, which is enabled by wireless technology. Okay, and in the home, you have a lot of things. Okay, like I told you, in medical, one of our customers has designed a swallowable tablet, a capsule, which you swallow, and it take pictures of your gut. Okay, earlier people had to do endoscopy. That means people had to swallow a fiber optic cable. Now they don't have to do that painful thing. They just swallow this one, and then it's real time. It transmits some pictures as it goes along. Another customer did something called a dental mirror. Okay, so doctor can put it, earlier the doctor will see in the mirror, okay, with his eyes. Now it's communicated and you can see on a monitor or record something. And then a lot of different wearables, not only wearables for us, but wearables for pets also. Okay, pet wearables is a big market for us. People want to track their dogs, okay, where they are. They want to be able to tell the dog wherever they are that please come in immediately. It's like a regular cellular connection for them using Wi-Fi. So they can call to the dog. If the dog goes near the garbage bin using a Bluetooth tag, they can find out the dog is gone there. And then the caller will actually give a sound, which will make the dog come away. And a lot of things in the industry. Okay, you can do amazing amount of things. Okay, I mean, a lot of agriculture is getting robotized. Okay, I mean, robots go and then you can pick. Some of them pick, even if you don't pick, they can carry back autonomously. And a lot of things are happening there. Okay, and if you go to our website, Silicon Labs website, you'll see a lot of applications that are listed, and we give actually application notes and descriptions of what you can do to create those applications. Okay, and in the home, I already told you that there's a lot of wireless technology. Unfortunately, there are so many companies. If I buy a Philips light, I use my Philips app. If I buy a Wipro light, I use my Wipro app. If I buy a Samsung TV, I use Samsung Smart Things. Okay. Similarly for LG, for Apple or Amazon, that is very painful, right? So all the companies came together, Google, Apple, Microsoft, Silicon Labs, Amazon, IKEA, and then they decided that enough is enough. Let us create a single protocol which will be applicable for devices made by anybody. So they all agreed upon a protocol where if you have a smart bulb, if you want to increase the brightness, this is the message that you're going to send. So now everybody is starting to use the same message. So you can use one app and control all of your devices. Okay, imagine how useful that is. Okay, once you have that, you can actually create a home automation solution, and you don't have to worry whether your customer has bought a Wipro bulb or a Samsung TV or anything. Whatever it is, it will be controlled by Matter. Okay, so a summary to all of this is that wireless technologies are enabling what is called as a $1 trillion IoT market. That is based on your imagination. You can create solutions. The technology is available. You can choose what protocol you want to use, and there's absolutely no limit to innovative applications. All right, so let's very briefly talk about careers before I open up 10 minutes for Q&A. Like I said, you can be an innovator, you can be an entrepreneur, you can be aware of what is there in the world. There are two things that are happening. One is that there are some people who are creating new technology. Okay. And there are people who are using the technology to create solutions which are reaching out to the market. Okay. If you're a hardcore techie, okay, you are really into software, hardware design, you want to, work on algorithms and you want to file patents and so on. Okay, you can file patents everywhere. If you are hardcore techie, you can work on technology creation. Okay. What kind of algorithms do you use for face recognition? How do you locate somebody in real time? Okay. Can you actually create a robot? Can you create a drone? Can you create a cloud computing platform that is very scalable and very efficient? Okay. Can you create a very efficient DC motor? And then there are other class of people who are always thinking, okay, how can I make people's life easier? How can I make them safer? How can I make the world more, easier to run? How can I make it easy for people to adopt technology and do things? So I have face recognition technology. What can I use it for? Fine, I will use it for a smart door lock. Okay, I'll put it on the door. When I come in, I have two bags in my hand. The door will open because the face recognition recognizes me. I don't even have to put my fingerprint. So let me create that. Okay, and then you have, when in a hospital you have doctors and patients. Okay, I mean, they may not be, the doctor may be anywhere in the hospital, so you can go and track where he is using real-time location technology. Somebody has created a robot. Can I use it for doing something hazardous? Right? Instead of me operating some hazardous machine near a furnace, let the robot operate it. Okay. I will use the robotics technology for my industry. Okay. I will use robotics technology for plucking strawberries carefully from each plant. Okay. And then you can do smart health devices. And now you get the idea, right? Okay. You can be in the application of technology area, or you can be developing technology area. And there are opportunities for everyone. A lot more people are applying technology than creating technology, but the challenges are equally interesting. Okay, now this is unfortunately, I mean, applies for the IoT and embedded systems and the semiconductor area. I went around to different managers in our company and asking them what they look for in students. Okay, so you will be surprised to know, don't need to read this, but the summary of all of this is all the top companies, they look at students to see whether they have understood the basics, the foundation of their subject. If you look at everything, whether you're in computer science or electrical engineering or electronics, you will find that all of these topics are covered in the second year and third year. Okay, so companies are not looking for a high funda project that you are doing in your final year or what internships you have done. Unfortunately, no. They are looking to see whether you have understood the fundamentals. Okay, and how do you understand the fundamentals? By first of all knowing that fundamentals are important. Okay, if you know that, okay, this subject was important, maybe you would have focused more on it. Now I'm telling you what is there in the second year is absolutely the most important thing for your career. If you understand that, you can build anything on top of it. And one way of understanding it is also to do things hands-on. You can actually build things, you can write software, you can, okay, try and apply it on your own, even if your lab is only limited. Okay, spend your other time doing something on your own. Get together with friends and build a project, build a robot, whatever it is. Okay, write some software, create an app, and then that will give you an insight into the fundamentals. All right, so I rushed it a little bit because I wanted some time.
So are there any questions? If you all can ping on the chat or maybe in the Q&A, sir can take that. Whoever is raising hand, can you all type your questions there? Or maybe I can just quickly allow you to talk, Harshita, right? I'm just allowing you to talk. Maybe you can ask your question.
Go ahead.
Um,
I think you may need to allow them to be unmute.
yes, I did allow.
Okay.
Uh,
If you have a problem, you can type it in. I hope typing in should not be a problem.
so is there no question? Then I am allowing Veeramani, if you have any question, you can unmute and ask. No, I think. So I have some questions. I am
Yep.
taking the question. So, sir, to understand, like as you mentioned, a lot of options of career options.
Yep.
So, is there any specific kind of specialization that the students must be doing now if they're in their UG degree, or any
Yeah, I
kind of
mean,
courses that they can do?
there are two things, right? One is, of course, to understand what is there in the syllabus. That's very important. The second is to keep your eyes and ears open. What is happening in the world today? Okay. For example, I mean, there is this whole thing called RISC-V processors. Uh, the world is moving towards open source. And not only software is getting open source, the hardware is also getting open source. The RISC-V processor is an alternative to ARM processor. So anybody can download the design, anybody can modify the design, anybody can use it to create their own hardware. Okay. And in the software world, the whole world is moving towards GitHub as a way in which you can communicate your code, and then you can actually comment on other people's code. A lot of companies are actually looking at GitHub activity and then deciding to hire people or students. So you can actually be there in the open source. And I know that in the college, okay, I mean, you're not supposed to use generative AI to help you, write assignments or exams or something. But in the corporate world, people are looking at how efficiently you can use AI, filter out what is useless from it and augment it with your intelligence and make something better. So how do you intelligently use AI for doing your work is also a skill all companies are looking for. Okay, and this is outside the syllabus of most colleges, but this is one of the few exceptions where outside the syllabus things are useful. So use Gen AI, but use it intelligently. Try to get used to giving the right prompts. And try to decide, okay, when you can discard the results and when you can use your own. Okay, and that's a very strong skill that people are looking for.
So,
Doesn't matter which field, all fields.
yes. So you mentioned about AI. So there's a question related to that. I'm just taking up that question. So in reference to your discussion of smart homes and appliances that can be digitally controlled, could you speak as to what is the current scope of AI in the development of these technologies? Is it being considered to play a part?
Yeah, it's a fantastic opportunity for people. Let's say that you want a really intelligent home. Okay, so you walk into your house, the smart door lock finds out who is coming in. Okay, it has already learned what are your preferences, what you normally do. Do you first go and turn on the TV, or do you go to your kitchen to make yourself some coffee? Okay, then I mean, you can even have the correct lights turned on. You can have your coffee machine turned on. If the TV is on, okay, if you like the lights to be yellow, you can put your yellow lights on. I mean, you can, if there is still daylight outside, you can open the blinds. A lot of innovative things can happen automatically. Okay, and if there are children in the house, okay, if the children wake up, can you be given an alert? Can you turn on the milk for them to be heated up? Can all of these things be automated? Yes, you can actually apply AI and create a smart home for different types of people, different needs of people, and the way you package it, people should find it attractive.
Thank you, sir, for answering that. So there's another question related to your presentation. Which organization handles distribution of different spectrums?
Yeah, so actually in India, it's actually the government, TRAI. Okay, so within India, so they allocate it, and the defense has allocation, the civil has allocations, and so on. Worldwide, also there are bodies like the International Telecommunications Union and the Federal Communications Commission in the US. So these are all central bodies, and India is also part of the ITU for global allocations of satellite frequencies. For example, we also discuss together, government to government. So ITU, TRAI, Department of Telecom, FCC, all these bodies actually work on allocating spectrum.
So there's another question. As a fresher, what companies will expect from the freshers?
Well, that's what the freshers should be equipped with the foundations of their subjects. Okay, the foundations are not going to be taught again. All the applications can be taught again. So first of all, people expect your foundation to be very strong. You should be able to retain certain concepts and be able to apply the concepts in solving some problems. Okay, so they might actually test you by giving a small problem to solve. You should know some of your basics to be able to solve it. Okay, that's the number one thing. Second is that companies expect students to be curious. They should be aware of what's going on. They should be reading things. Okay, if somebody says, okay, I mean, DeepSeek is suddenly coming in. Why is DeepSeek suddenly getting so much attention? Okay, curious students, okay, get their knowledge expanded and do things. And the third is the ability to intensely focus on solving a problem. So they may give you in the interview, they'll give you a problem to solve. It's not that, okay, they could have given it to you in the written test also. But they are trying to see what is your reaction. Do the student want to say, I will go to the corner hall and bring it back? No, but tomorrow in front of your customer, the customer gives you a tough question, you have to solve in front of him and answer in front of him. You have to be bold enough to do that. Secondly, you have to be interactive. That is, can you arrive at a solution, okay, even if you don't know the answer directly? Can you now talk to the interviewer and say, I don't know the answer, but I'm going to try. Okay, I'm going to start from here. Okay, and then the interviewer will happily, help. Okay, whether you're on the track or off the track. Remember that companies, the people are coming to interview students, hoping that they'll be part of their team. So the person who's hiring will need to be comfortable that, oh, this is a guy who can listen to me. If he's off track also, he can take my inputs, then he can think and come back on track. Okay, yes, okay, I mean, tomorrow he'll be useful for me. So you have to create that bond of being able to, it's not just a plain Q&A, it is how much comfortable the manager is in the belief that you can be a useful member in his team. Okay, so these things, okay, I mean, can go a long way in making you attractive.
There's another question I would like to take. So which sector of electronics industry will be having a boost in India in the upcoming years? Is there any specific industry?
Well, actually, India is one of the largest consumers of electronic products. Unfortunately, most of them are imported or manufactured in India based on a design from somewhere else. But the spread of electronics is tremendous. So there's a lot of scope for India developed products. For example, okay, I mean, even something simple like, those devices which if you pay money, it reads out how much you have paid, right? Received Paytm payment of so and so. Even a person selling, bananas is having it.
Yes.
That is the reach of technology. And imagine if that had been created, developed, and manufactured in India, right? And that is one thing. And let's say that the ceiling fans now, BLDC ceiling fans are one-fourth the power. Now, every year, some 40, 50 million ceiling fans are being sold. Starting with Atomberg, now almost every company is selling BLDC fans. They are an India-specific product because every home in India has 4, 5 ceiling fans. And if the technology has been developed here and it owned here, we would have made so much out of it. Unfortunately, the technology came from China. Many companies are adopting it here and doing it. So today the government is talking about manufacturing. Okay, so if we are importing electronics, why don't we manufacture here? So there's a big, fanfare about Foxconn making iPhones in Chennai, right? But remember that for each iPhone that people pay, okay, 80,000 rupees, okay, Foxconn maybe gets about 5,000 rupees. Okay, the rest of the component, the chip, okay, may go for 5, 6,000 rupees, 10,000 rupees. The whole cost of the phone is less than 35,000 rupees. And the remaining 50,000 rupees, who gets? Apple. Why? Because they designed it. They are not manufacturing it. They are not manufacturing the chips here. Their software is written by people in India also. Apple has got a large team in India. But for every iPhone sold, more than half the money goes to Apple. So we need people here who can develop the products with a headquartered in India. You can get it manufactured in Taiwan, no problem. You can, hire a team in Vietnam to write software for you, no problem. But eventually in the product, we want to have the maximum margin for yourself. So the government is struggling hard to make sure that there are people who can visualize and create a product here. Okay, so being aware of technology that is coming up and being aware of how technology can be used in the Indian context and how can you create such a product that has the biggest market. You'll find lots of companies now coming up, which is in this particular field. All of them will apply technology to solve real world problems.
Thank you, sir, for answering that. I'm just taking two, three questions combinedly. So there is one question that are there opportunities in your current organization as a fresher? And so what are the different domains? Generally during the placement, the companies like yours look for. Is there any specific that they have to be prepared for? The technical sort of questions, the concepts, those kind, and the technology that they should be, current technology they should be aware about.
Yes. Yeah, we actually, our company was not a very large company, but every year we take maybe about 50 freshers. They are all, unfortunately, most of them are engineers, by one or two people MBAs, but majority are engineers from computer science, electrical engineering, electronics engineering, and related areas. So we have software, we have different types of software, we have chip design, we have board design, we have signal processing, we have communications, we have analog design, digital design. We actually take people in different areas, and most of it is through direct contact with the college placement offices. So we go to 30, 40 different colleges every year. Maybe not every year, but at least they are there in our list. And what people should do is to be able to reach out and try to become part of our bank of colleges to whom we go. And today, okay, a lot of focus on internships. We want to take people as interns first, and if they are good, then we want to convert them. So, internships is becoming a primary way of recruiting for many companies right now. So, but it's all official. The sense that we want to establish a relationship with the college so that we can go to the college every year. The seniors will tell the juniors Silicon Labs is a good company to work for, so they look for people with these kind of skills, so why don't you focus on it? We want that to spread around.
And is there any specific kind of a technology that the student should look ahead and be, learning or something like that?
Yeah, so everybody needs to write software. No matter what field you are in, whether you're an engineer or not an engineer, you should be able to write software. You should be able to write scripts. You should be able to use something like Python or something. Okay. Even if you can't write software, you should be able to use vibe coding to have AI tools write software for you. That means you should be able to specify what you want. Okay, so that's a common technology or skill that is needed from everyone. Okay. And then we are looking for people with the right concepts in both software design and hardware design. Like I said, okay, for people in hardware, the a good grasp of digital electronics is very important. For software, a very good. You should literally write hundreds and hundreds of programs through your college. C programs, Java programs, Python programs. At the end, okay, you should have written 200, 300 programs. Some small, some big. Keep on writing. Okay, so those are some of the basic things that we expect people to do. The use of AI, okay, yes, AI is something that has made everybody a fresher, right? I cannot say I have 40 years experience in AI, right? Because AI has not been there. So that's a great leveler. So if you have used AI for 3 years, remember you are one of the senior most AI people in the whole world. Okay, so that's a great opportunity for people to explore it and how you can use it usefully. Okay, people waste a lot of time trying to create some weird images and so on. Okay, that's not the use of AI. The use of AI is to solve a real world problem and use it to make you more productive.
Yes. Thank you so much, sir. One last question. This is something very interesting, so I just kept it for the last. So using of the digital technology in day-to-day life, isn't it concern to health? So what is your take on this? And also, I would like you to conclude with some takeaway good points for the students.
Very good. Yes, Technology can be used for both useful and not so useful purposes. We, as engineers, okay, we are developing something new and innovative, but is it the right thing to do? Okay, so there is something called ethical design, and a lot of people are in favor of it. Okay, if you have an innovative idea in mind, we don't want we don't want to use it for the wrong thing. For example, you don't want a startup to create one more gambling application. Okay, we don't want a startup to write one more game that is addictive, right? We don't want someone to actually try to hack things and try to do something illegal. So there are a lot of ethical things that happen, and health today can be ruined by not being active and being overwhelmed with stress. Okay, mental health is even bigger problem than physical health. Okay, so we don't want time to be taken away. Technology should save time so that people can relax more. Okay, not don't I mean you should try not to consume content, be a content creator. Okay, don't be a consumer, because that can suck away everything from you. Okay, so digital technology should be able to help you keep life on track. Okay, am I spending too much screen time? Am I not spending enough time on some things which are outside my laptop? So yeah, you can actually use technology to make it better, but you have to really be on the guard, because in general, uh, everybody wants a portion of your time. Okay, every person who is selling things, he wants your time in some way. Okay, so you have to be on guard for that. Okay, so final thing is that, I think I'm very, jealous of all of you folks. You are all, at a stage where things are growing so fast, so rapidly. Things are changing so, amazing things are happening, and you are able to, be part of that revolution, really. Okay, so it's a golden opportunity for all of you to, make an impact and make an impact positively. Be There are two things that we all look for. One of them is intensity. Whatever you do, focus on that. Okay, 2 hours you want to finish this. Don't think of anything else. No distraction. People who can work on that intensity on that really go forward. The second is enthusiasm. Whatever you're doing, you like it. Okay, don't wait for it to be over. Okay, do what you like, or if you choose a particular field, decide to love it. Okay, and then you can automatically get your energy to work more. So I like what I do. When I do something, I like to do it, okay, with the fullest of my focus, but I like to spread things around. Okay, I play tennis every morning. I go cycling on weekends. 40 kilometers I went the other day. Okay, physical health, mental health. Okay, spending time with family and children. Doing forums. Okay, I'm a volunteer. I'm a mentor to so many startups. So every time I talk to them, I have to get into their world. It's all very interesting. Okay, so keep yourself, make the variety give you energy for doing things. Don't get bogged down in one single thing. When you do join a company, remember that the company is not end of your life. Okay, always look to see how you can keep growing. Are you adding value to yourself? Okay, at the end of 6 months, you might have added some, say, 12 lakhs to your bank balance, but that is one part. But how much value have you added to yourself? Every 6 months, look back. This is what I've learned. This is what I've become better in. So if you can keep improving your value balance, then you can grow much faster. Okay, never have a 6 month period when I said I'm exactly the same as I was before. No change. Okay, I'm still doing the same thing. I'm not learned anything new. Okay, try to avoid that by having periodic reviews and take on mentors. Okay, a lot of people like to mentor. Okay, try to get a variety of mentors on which some people you will ask something, some other people you'll ask something else. Try to learn from others' experience and try to be open to the world around you and be curious. Okay, so and then all of you will have a fantastic future ahead. It's really mind-boggling what people can do. I have a lot of people in the US saying that they are very envious of India. They said that I want to go to India and work. That's the fastest growing country in the world. Okay, so you're lucky to be here. Don't think of going anywhere else. Action is here in India.
Yes. Thank you so much, sir. And on behalf of the team Pod.ai and also the MentorCloud, I would like to thank you. And I think this was a really interesting session. A lot of students have gained insights about the wireless communication and the different things which is coming in the future. And I think a lot of would have not been aware about it actually. I mean, they've been studying. It's just like the practicality of it. They are not aware about it. Everybody might be using it,
Yeah,
but then I think you brought in a little different perspective towards that. And thank you so much for giving your time. And thank you so much, everyone who has joined for the session. I can see a lot of questions still coming, raising hands, but I think we have to end the session as almost 20 minutes apart. So I'll just take a quick. I mean, you all have taken a good time, and thank you so much, sir. And you
yeah.
all can always maybe connect with sir, if you
Yeah, you
uh,
can connect with me, look for me, and I also
on
gave
LinkedIn,
my
yes.
email nvenkatesh@IEEE.org. I always reply to everybody. And if you want to connect on LinkedIn, please send a note. Okay, because I have about 400 connection requests. I don't know who they are.
Oh,
So
wow.
introduce yourself. Okay, tell and how you came to
Hmm.
know about me, and that will give me the urge to connect you. Send me email. I don't respond. I don't ignore any email. I will respond.
Yes.
Okay, so
So
I'm
what
here
one
for you, and yeah,
yes, one personal question, sir. Like, I mean, not that I can go back and practice now. So I've also done my electronics and communication engineering, but then I want to understand now that I have turned to journalist. So
mm.
I just wanted to understand, is there do you also provide career guidance to the students, or do you also mentor students from the colleges for their projects and all? Is there an option that?
Well,
So.
yeah, I mean, actually, we do it officially also. So we are opening a center of innovation in IoT. We opened it in several colleges. For the
Mhm.
company, we do it, and personally also. Okay, I've taken on a couple of mentors on my own this summer. Uh, so there's an organization called INAE. I had
Mhm.
them apply through that so that they can get a stipend also. But like I said, okay, I always respond to people. And I know I'm also passionate about writing. I've written lots of articles in technical journals and so on. Okay, I mean, I have actually, there's a field called technical writing.
Mhm.
Companies employ writers who are engineers who can understand stuff, but can write it in a way in which the end user can understand it.
Yes.
Okay, so for the last 30 years almost, okay, I mean, I've been kind of training technical writers
Wow.
and getting people to, do communication of technical technology stuff in a way in which everyone can understand. Okay,
Oh.
so I'm very happy that you are in the creative writing area. I mean, do send me examples of what you have written, and if you want to collaborate on writing something, I'll happy to do with you.
Sure, sir. Okay. Thank you so much, everyone, and thank you so much, sir.
Yeah,
It was really nice session, and I hope students are still can follow you on LinkedIn or something, and
yeah,
then connect with you.
sure.
All of you stay curious and stay connected. It
Yeah.
was really a nice session. Thank you so much, everyone.
Bye.
Bye bye.
Hi, Sarah. One quick question. Do we need to end the session on the YouTube live as well, or does it